Welcome to my YouTube channel Knowledge Entertainment, and once again we are here with the next lecture on complex numbers and quadratic equations. Before moving ahead, once again I request you to kindly subscribe my channel, like my videos and share it with 10 plus 1 needy students who cannot afford coaching, etc., so that they can prepare for their board examinations and competition examinations as well. So here is the third lecture on complex numbers and quadratic equations. In the first two lectures, we have discussed several properties of complex numbers and solutions of quadratic equations, and now we are moving on to the questions of complex numbers and quadratic equations. So here is a question. I am starting with very simple questions, and slowly I'll move on to the typical questions. You can say the questions important from point of view of examinations then. So first question is, express 3 plus 2 iota q as a plus iota b. So what you have to do, you are actually to find real and imaginary parts of this number. So how to do that? This 3 plus 2 iota cube, we know that a plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. So that formula I'll apply here. So it will become a cube, this is your a, plus 3a square multiplied by b is 2 iota, plus 3a and b square plus b cube. And now, just to simplify it, 3 cube is 27 plus 3 into 3 square is, once again it is 3 cube, so it is 27 multiplied by 2 iota plus, this is 3 into 3, 9, and 2 iota square is 4 iota square plus 2 iota cube is 8. I am writing it as iota square into iota, because we know that the value of iota square is minus 1. So substituting the value of iota square equal to minus 1, wherever there is iota square, what we will get? It is 27 plus, now it is 27 into 2, 54 iota plus 9 into 4 is 36, and this iota square is minus 1 plus 8 into this iota and multiplied by iota square, that means minus 1. Now once again simplify. So it is 27 plus 54 iota minus 36 and minus 8 iota. 27 minus 36 is minus 9, and 54 iota minus 8 iota is plus 46 iota. So now this number 3 plus 2 iota whole cube is expressed as a plus iota b, where a is minus 9 and b is 46. That means real part is minus 9 and imaginary part is 46. So it was the first question. We'll take another question of this type. So a little bit more typical question you can say, but still easy, not difficult too much. So express 3 plus 4 iota, or you can say 3 minus 4 iota raised to the power 4 as a plus iota b. So this 3 minus 4 iota raised to the power 4, and we know that how to obtain the coefficients of a power of sum of two terms. For example, if I am writing a minus b power 4, then how to solve it? To solve it, what I'll do, I'll start with A4 minus alternate sign, positive and negative. So second one is negative. I'll reduce one power, so it is A cube, and I will introduce B. Then once again plus, minus, and then plus. So one power again decreased 2, and one power increased of B square, minus, because after plus once again minus. So A square, one power reduced is A, and B square increased is B cube, plus B power 4, but still coefficients are missing. So for coefficients, I'll go to this 1, 1. These are the coefficients in A plus B power 1. Then I'll write 1, 1. I'll write below middle of these two ones, sum of these two, 1 plus 1, that is 2. So these are the coefficients, 1, 2 and 1. These are the coefficients for A plus B square. Once again, 1, 1, 1 plus 2 is 3, 2 plus 1 is 3, and these are the coefficients for A plus B raised to the power 3, or you can say cube, even minus you can say. All what will be changed, the signs will be alternate, plus minus. And then once again 1, 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So these are the coefficients for power 4. We are having power 4. So these are the coefficients. This one is the coefficient here. So it is 1, A power 4 means A power 4. Then next coefficient is 4. Next coefficient is 6. Next coefficient is 4. And the last one is again 1. So 1 B4 is B raised to the power 4. So this is how to expand A plus B raised to the power 4. And that we will use here in this A minus B power 4. So here your A is 3 and your B is 4 iota. So use this formula, A power 4, that means 3 power 4 minus 4 into A cube. So 3 cube, then multiply by B. B is 4 iota, plus 6 A square, B square. So 3 square and 4 iota square. After plus, once again minus 4AB cube. 4A, A is 3, B cube, 4 iota cube. And the last term is plus B power 4. So it is 4 iota raised to the power 4. And now we are just to simplify this expression. So how to simplify it? Let us see. 3 power 4 is 81 minus 3 cube is 27, and 27 multiplied by 4, 108. So it is 108 multiplied by this 4 iota, plus 3 square is 9. 9 into 6 is 54, and this 4 iota square is 16 iota square, minus this 4 into 3 is 12, and this 4 iota cube is 64 iota cube. I am writing 64 iota square into iota, and the last is plus 4 raised to the power 4 is 2 raised to the power 256, and iota 4 is iota square, once again square. And now once again simplify. This is 81, then 108 into 4 is 432 iota, plus multiply 16 and 54. So it is 864. Iota square is -1 minus this 12, multiply it by 64. 768. This iota square is -1 and one more iota is there, plus 256, and iota square is -1, square of it. Simplify further. 81 minus 432 iota, and this is now minus 864. This is minus and minus plus, so it is plus 768 iota, and the last term is plus 256. So there are three terms in which there is no iota and two terms in which there is iota. So you are just to simplify that, these three terms, this 81 and plus 256, it becomes 337. So 337, and there is minus 864. So when you will subtract, it will become 527. So it is 527, and then this is minus 432 iota, and this is plus 768 iota. Once again, simplifying, you will get plus 336 iota. So this 3 minus 4 iota raised to the power 4 is being solved, and now the real part is 527 and imaginary part is 336. So we will solve more questions. Now I'll move on to a little bit different problems. So another problem I'm going to take here is find multiplicative inverse of multiplicative inverse of 5 plus 3 iota square. For solution, what you are to do, first of all, simplify this complex number. This is 5 plus 3 iota square. That means 25 plus 60 iota plus 9 iota square. And iota square is -1. So it is -9. 25 minus 9 is 16, and plus 60 iota. This is your Z. This is your Z. Now, multiplicative inverse of Z is Z bar over mod Z square. So what it is now? Your Z was 16 plus 60 iota. So Z bar will be its complex conjugate, 16 minus 60 iota, and in the denominator mod Z square. So your mod Z is under the root 16 square plus 60 square, and then square of this. So what you will get? 16 minus 60 iota divided by this square root will be cancelled by the whole square, and you will get 256 plus 3600. So it is 3856. Now you can write the multiplicative inverse of Z as it is, or you can separate the real and imaginary parts. You can reduce it to the lowest terms to find the simplest form of the multiplicative inverse of this number, 5 plus 3 iota square. Another question we are going to take now. The next question I'll try to take a little bit different question now. So another question what I'm going to take, express 1 plus iota over 1 minus iota square as a plus iota b. So I'm to write this number in the form a plus iota b. Question is simple, but you'll have to train your hands on such questions so that it will become easy to handle difficult questions afterwards. So here this question is 1 plus iota over this 1 minus iota whole square is 1 minus 2 iota and plus iota square. We know that iota square is equal to minus 1 and here it is 1. So minus 1 and 1 will be cancelled out. You will be left with 1 plus iota over minus 2 iota. So the easiest way is to now multiply and divide by iota. This 1 into iota is iota, plus iota into iota is iota square, and iota square means minus 1. In the denominator, minus 2 multiplied by iota square, that means minus 2 multiplied by minus 1, so it is 2. Now you can write it as minus 1 by 2 plus 1 by 2 iota. So we have expressed this number as a plus iota b, where a is minus 1 by 2 and b is 1 by 2. That means a real part of this number is minus 1 by 2 and imaginary part is 1 by 2. I am doing a little bit simple questions now to make you handy on questions of complex numbers and quadratic equations. So another question, another simple question I am going to take. If x plus iota y is equal to a plus iota b cube, then express x upon a plus y upon b in terms of a and b. The question is easy. We are given that x plus iota y is equal to a plus iota b cube. I can simplify the right hand side by opening the cube. What I will get? X plus iota y is equal to a cube plus 3a square b iota minus 3ab square minus 3b cube iota. So this is the simplification, and now I can collect real parts and imaginary parts of this equation. So it is a cube minus 3ab square plus iota common from these two, it is 3a square b minus 3b cube. Equating real and imaginary parts from both sides, your x is a cube minus 3ab square and y is 3a square b minus 3b cube. Now divide both sides of the first equation by a and both sides of the second equation by b to get, if you divide both sides of this equations by a, you will get x upon a is equal to a square minus 3b square, and dividing second equation both sides by b, you will get y upon b is equal to 3a square minus b square. And now simply add these two equations so that x upon a plus y upon b is equal to 4a square minus 4b square, that means 4 times a square minus b square. So this way we have expressed x upon a plus y upon b in terms of a and b. So now I'm going to stop this video here. In the next video we will take more and more questions on complex numbers and quadratic equations. Thank you once again.